Hey there, welcome back to Coding at Home. Hey there, I'm Matt with the Code Hub. Welcome back to Coding at Home. Today we're going to be playing with Sensor Arcade a bit more. We went and downloaded that playground from the More Playground section of your Swift Playgrounds app yesterday, or the day before if you were really on the ball. And we completed our Catching Cupcakes test yesterday. So we're going to look at a little bit of the code that we had for that. I had to recreate some of it because I accidentally deleted it. We'll have a look at the next challenge, Dashing Donuts. This is going to use the light sensor in our iPad, which is also the camera. So we'll get certain events triggered when the light changes. And we're going to try to explore that a little bit and see what gets sent with each one of those events. So let's hop over to the iPad and give it a shot. All right, so first things first, we're going to open up Swift Playgrounds on our iPad again. Here's our Catching Cupcakes code. I changed a little bit of it because as I said, I deleted some of it by accident and I had to recreate it. I changed a little bit in here. I cleaned it up a little bit. So we had the handle touch move position. And we use the player position. We set the player position to our touch position. So we're able to kind of tap around the screen on the cupcakes, and immediately the player's little avatar will be set onto that cupcake. So we'd get a ton of cupcakes. Now my high score was 20. The guys downstairs said they got 23, I believe. Not bad. Better than me anyway. So good job. And here, I'm just going to fix this a little bit because we're a little bit too big for our screen. So let's fix this so you can actually see the whole screen. There we go. I also had this handle touch moved apply impulse where we figured out the difference between the X position of our touch, so on this X axis, and the position of the player. So say if the player was centered in the middle, that would be 0. And if I was over here, my touch position on the x-axis would be, say, 200. So my x direction is going to be 200. And then same thing with my y direction. So wherever my touch is, so say it's up here, and if my player is on the 0 on the y-axis, the y direction will be 200. And if I touch over here, the X position will be negative. If I touch down here, the Y position will be negative. So we just do a little bit of math, and then we feed those numbers that we calculated into our apply impulse method here on player for the X and Y parameters. And that lets our player bounce around the screen. So in my on touch handler here for the scene, I handle the touch moved position, or I handle the on touch moved event with the handle touch moved position function. If I changed it and I wanted to make it a little bit more entertaining, I might use the handle touch moved apply impulse. Now I have a small problem here if I just tap autocomplete, because now I have touch in parentheses and then touch in parentheses again. So I'd have to delete one of those anyway. So we'll just hit delete. And there we go. If we run our code, we'll see what it looks like. We'll practice. There, I can tap around, tap over here. Then he hops up, tap over here. So this could be a much more entertaining game because there's a bit more challenge than just going and tapping on the cupcakes. Now, if we were really concerned about getting cupcakes, obviously we'd use the handle touch move position because we'd want to be as efficient as possible getting our cupcakes. So that was the work we did yesterday. We didn't do too bad. I think our high score with the apply impulse method was 14, so it was a bit harder to get a higher score. So if we were making this a real game, we might want to change the point value to make someone feel like they're getting more points, even though it's that bit more difficult than the touch, moving the player's position to the touch position. So that's touching the screen, and this is amazing because now we can take a person interacting with their screen figuring out where they're touching on the screen, and have our different elements react to that touch. I think this is unbelievable because you can really build some really intricate apps, some real in-depth interactions with your users, and I think it's amazing that we're doing this after just a few months of coding. All right, so now what we're going to do is we're going to move on to the next screen. So we're going to go on to Dashing Donuts, my personal favorite. So if you're ever thinking of sending me anything, feel free to send donuts. All right, so the goal here is your player scales up and down, but it can't reach all the donuts. We want to edit the code to score more points in the game. So this is going to be using the light sensor. So we're going to create an instance of the light sensor. We're going to tell the device to start collecting data from the camera. And you remember, we talked about instances when we talked about types way back when in Everyone Can Code Puzzles. This just tells you that an instance is a value of a particular type. For example, in let motion equal motion sensor, motion is an instance of type motion sensor. And this is the initializer with these two parentheses at the end of our motion sensor type. Okay, so now what we're going to do is we're going to run our code and put our hand over the front camera. So we're going to be using this front camera on our iPad. And we're going to put our hand over the front camera and notice that the brightness data that we get is going to change. So we'll use a few of these different methods here. We've used apply impulse. We've used move by. We'll try the X scale and Y scale and move to as well. So we're going to use the brightness data to move that player up and down. So with this playground, we're all about exploring different values that we can get from the sensors. So different input is what they call it. So we can detect different environmental things, like the way a player is touching the screen, like the way they've got their hand over the camera, or maybe the way if they're in a car and they're traveling through a tunnel, the light changes and the color of the light changes. So let's try running our code. So what we're going to do is we've got our variable that's a light sensor. Here's the initializer, and we can pass in a configuration with a dot front. I'm guessing there's also a dot back for a light sensor, so we can get light information from the back camera. Here's a function called handle light update, and it takes a color type, and we're going to call that light that we're going to write that we can use in our function here. And in this one, what we're doing is we're just changing the scale of the player based on the brightness property of the light parameter, and we're multiplying it by 5. That's what that asterisk does, is it multiplies by 5. And then we tell the light sensor to set the on update handler to handle light update, and this code will get run anytime the light sensor detects a change. And at the very bottom, just like we saw on the previous page, the page difference set to .media. So let's run our buttons. In practice, the goal here is to see how far we can hit line blocks and jump over obstacles and get all the nuts. Okay, let's practice. So there's my robot. So if I hand over the front camera, I can see the brightness is changing. We'll load up the brightness. And towards the window, it gets even brighter. And if I hand completely over the camera, it shrinks. That's good to avoid obstacles that are over our head. So let's get a hint and see maybe, well, because now we're not moving anywhere, we're just practicing, we're just seeing how our code shapes. We can try changing stuff, we try making our little weird looking robot jump. We can get scale in a different way. Let's check out the and see what else might do. So saying that we could use the light sensor in the apply M method. We could apply y-axis, so up and down.
Really slow and kind of cut out or really
Yeah, it's really slow. I noticed that the feed is slow. Let me try going to air server.
Okay.
All right, good fact. All right, we're gonna switch again because man, really, we're gonna add more of them here. All right, let's try starting up air server so we can just AirPlay over. Hey there, welcome back to Coding at Home. In the middle of our session, sorry about that, we had a small crash. So we're in the middle of looking at our Sensor Arcade playground, and Dashing Donuts, most importantly. You don't want to miss any of this. So let's bring in the iPad and we'll try this again. All right, so here's where we were. We were in Dashing Donuts. We'd already kind of covered catching cupcakes, where we went over some of the different methods we use to actually catch the cupcakes using the touch sensor that's built into the screen of the iPad. Now what we're going to do is we're going to use the light sensor in the camera. And we wrote this function here, or we didn't write it, it was written for us, called handle light update. It takes a light parameter that's of type color. And we multiply the brightness of the light, the brightness property of our light parameter, by 5 to change the scale of the player. So it's still running. So if I move my finger over the front camera, you can see that I reduce the brightness. So it gets crazy small. And you can see that brightness is going up in this room about to 0.9. See, when we shine a light directly on it, brightness goes all the way up, I think as high as 1, and that's about it. So that's about as bright as we can get here. So we're going to use this to try to avoid some obstacles. Let's hit play and see what's involved in the actual game. Actually, if we tap on this thing, here we can actually change. This is a really handy thing in the practice mode, is we can actually change the type of light. So if we tap on this item up here in the upper right hand corner, we can change the properties of the color that's being passed in. So right now I have it as bright as it can be. So brightness is 1.0. And then if I drag along this slider, you can see the brightness goes way down until our player shrinks away. And we can change the color over here too. We're not using the actual color of the light. Since right now all I have in this room is I don't have any colored lights, unfortunately. All I have is sunlight coming in through the window and a couple desk lamps. So let's try playing this game and see if we can beat the game, see what kind of score we can get using just this pre-built code for us. So let's hit play. There we go. So we're walking along. Oh, that's not bad. Oh, I didn't get donuts, which is kind of a bummer, but I ducked under something. I'm using the spring to jump over stuff. Still not getting it. Oh, I got 1 donut. That's good. 2 donuts. Oh. Hit a bomb. That I don't think that can be good. Oh, jumped over that one. Actually, we're doing pretty well. We're flying along. If I just leave the brightness as is. Oh, this is probably the best I've ever done in this game. Oh, and when we hit something that we can't get by or that we don't shrink fast enough, that's when the game is over. So we can keep going to the next page, but what we're going to do is stick on this one, and we're going to try to refine our light handler and see if we can write some better code here. So let's go back. So my high score is 63.2 meters, and I got 4 donuts. Okay, not too bad. Let's hit practice, and we're going to try this again. All right, so I'm going to get rid of the sensor. Actually, we're going to leave that so we can play around. This will give us a handy way to test out our code. Leaving on this, the sort of light play around thing. This is how we turn it on. If we touch on that button there, that's how we get the these light sliders to show up. So let's see. So if we stop and we reset this page, we're not going to lose anything because we haven't written any code yet. But I just want to be able to get the hints back. So let's take a look at those hints. So that we saw a lot of donuts up in the sky. So we want to be able to use that brightness sensor to fling our player up and get some of those donuts. So let's try using this apply impulse function. So we're actually going to write a new function like we did the other day. And we're going to call it func handle light update oops, so it helps if I spell right. And then we're going to call it apply impulse, because this is what we're going to do. We'll let ourselves know just by the name of the function what it is we're going to do roughly inside the function body. So they've actually got the code written for us right here. We'll just do player.apply impulse. We'll keep the x coordinate 0, so it won't apply an impulse this way. It'll just apply an impulse this way. So let's bring up the keyboard. We'll say player, use autocomplete, dot, apply impulse. So we'll start typing apply. We can apply a force. We can check that one out as well. So just like the hint, we'll do it 0 is x. And we'll try using the light brightness property. So we'll hit the, let's get light dot brightness. And then we'll use multiplication. So it's over here over the G. So drag down times 50. Now remember the light brightness that we saw before was, it never got higher than 1.0. That's why we're multiplying it by 50. So it went down as low as 0. And it, kind of stuck in the 0.83 range in the room with the general light that we had here. So that's why we have to give it a little boost by multiplying it by 50. This is kind of a useful function to write and to use the events that are being passed in, because you can inspect the events that are being passed in and figure out generally what values they have. So you can say, okay, well, a 1 is not a very big, to change it by 1 on the y-axis is not very big. Maybe we need to translate that to how you're going to move on the screen. Now I have an error, and we saw the same thing yesterday. If I tap on the red dot, it'll tell me I have a use of unresolved identifier light because I didn't add the parameter to our new function. So let's tap on these parentheses over here. We'll drag from these 2 dots at the end to add a parameter, and we'll just call it light. And it's going to be of type color. Now, that's our handle light update apply impulse, and let's change that. So we're going to say, put the cursor after the handle light update, and we're going to tap on handle light update apply impulse, because that's the function we want to have run when we get an update from the light sensor. Now, before we run this, let's check out some of the other hints. Okay, so it says to collect all the donuts, which is what we didn't do, our player needs to move up and down in the scene. So below is some pseudo code. So what that means is it's code that's not necessarily going to run, but it sort of tells you the intent of what it is we want to do. So this says try filling it in with real code inside the handle light update function. If you need more guidance, move on to the next hint to see an example. So if we read through this pseudocode, this is kind of how you might describe the problem if I had asked you to describe it to me. You might say, well, if the brightness is greater than or equal to 0.5, go up, otherwise go down. That sounds reasonable. This is kind of like what we're doing in apply impulse. We don't have our if statement here. Let's check out some of the code that they've written to actually implement that pseudocode. Okay, so they've added an if light brightness is greater than or equal to 0.5, they apply the impulse of y30. And otherwise, they apply the impulse to go down. So if the light is constantly bright, our player will constantly rise to the top of the screen. And when we cover over the light, it'll get pushed down to the bottom. Well, let's try out this one first, and then we'll go implement this logic here. Let's try it out. Okay, so as you can see, the brightness is 0.82, and our poor little player keeps rising and rising and rising. So now if we cover over the sensor, we can see that it's dropping because it's applying much less impulse on the y-axis. And if we bring it all the way down to 0, so this will be very hard. Even as we're swiping around here, this will be very hard to control our player and actually get donuts. So let's try fixing this. Let's go back to the hint and take a look at it. So okay, so what they're saying is that if the brightness is over half, then we want the player to go up. So let's try that. So we're going to add an if statement from our autocomplete bar. And we're going to use the property on the light. So if light dot, and we can see that we have other properties on our color type here. So we have an alpha, which is how transparent or opaque it is, a blue component, red, green, saturation, and a hue that we used the other day in Sonic Workshop. But let's use brightness. And we're going to use, this is handy, in the autocomplete bar, we have a greater than or equal to. So 0.5. And if that's the case, well, actually, we'll just use this. We'll drag, whoops, we'll drag too far. We'll drag here. So instead of using the light brightness, they actually just hard-coded 30. So let's do that. Let's use, instead of making it variable based on the light's brightness, we're just going to set Y to, well, you know what? We're going to actually use 50. And now to add this else statement to push the player back down, we'll tap on the dots here. And from the menu, we'll add an else statement. And for this is where we're going to add a player dot apply impulse. So the X is going to be 0 and the Y is going to be minus. Let's do minus 50. Keep it consistent. So let's try running it. We'll get rid of the hint. Okay, that's good. Maybe we need to give it a bigger number so that it moves quicker. Maybe we also need to change the scale so that our player is a bit bigger so it's easier to catch those donuts. Let's look at the hint again. So that's one way to fill in the pseudocode. So there's a bonus. Ooh, that's cool. So create a new label to show other color data. So just like any other element that we add to the scene, we can add a red label. And when we handle the light update, we can actually update the red label text. That's very cool. Let's try doing that. Let's try checking out the red component of our light. So here we're going to create at the very top, underneath the light sensor, because I'm going to try to group where I create all my variables together if I can. We're going to create a red label, and I'm going to want to change it, so we'll make it a variable. So red label, and there's a type called label, so let's go grab that. There it is in our autocomplete bar. So I'll tap on that, and I'll use the open parentheses to get an initializer. And we have a text string color. So let's use that, because then we can set the color of the label and we can set a string for it. So for our text string, we're going to use this string literal here. And instead of ABC, we'll want it to say, well, I like their thing there. It says red. We'll say red, colon, and 0 to start with, because we'll update this when we get an update from our light sensor. And this way we'll also see how frequently it gets updated. We've already kind of seen it with the other label we have on here that gets updated with the brightness value. Now we got to pick a color. Let's pick red instead of white. And if I let it autocomplete, if we just do dot, because right here we have a dot white. No, I guess we're not going to get our colors auto-completing. Okay, so that's cool. So now we have our red label. Now to get it on the screen, we have to place it in the scene. So we have a scene property. Scene.place. Now red label counts as a graphic, so we can say red label at point. And let's put it where they put it. So point. Pick the parentheses. Pick our X and Y initializer. And we'll say minus 350. And the Y value will be 325. 325. And now you see inside the handle light update function, they just update the color. And they say light sensor, current sample, dot, red component, dot string, fraction digits 2. Okay, interesting. Let's try it out. Now we're not using this light update. We're actually using this one here. So we'll add that code after we've played around with applying the impulse based on the brightness. So we'll do red label dot text. Now we're going to set that equal to. So you can see we have a string here, so because we have the quotation marks, so we'll get the quotation marks from over the L by dragging down. So we'll do red, colon, and then a space, because you see the space before the final quotation mark. And then we have a plus. So instead of coming up with, red plus green equals 4, when you add two strings together, you sort of mash them together into one string. So let's do that. The string that we get is this one here. We actually turn this red component into a string. So here they're using the light sensor. Let's do that. Light sensor. And remember, we'll pick not this one. This one's the type, the one with the capital L. This one with the lowercase l, that's our property. So we'll tap on the light sensor. Dot current sample. If we hit dot, we'll see the next properties we can get. So there's blue, red, green. We could have also potentially grabbed this from our light parameter here. Might be a different option. And now we'll turn that red component into a string with the number of digits after the decimal point in our fraction of 2. So let's try running this and let's see what we have. Okay, cool. There's our red label. Looks like the red label kind of matches the brightness, doesn't it? Now, if we move this guy, though, you can see that it's different now. We've got the actual color being fed in is more green now. And you can see that no matter what brightness we have, the red stays 0 because we're as far away from the edges as we can be. Now, if we go more towards purple, you can see that there's more red in the actual light that's coming in. And if we push it all the way over the edge, we have a ton of red when the light's being fed all the way through. All right, well, let's try playing this and see how our logic works out. Let's hit play. Here we go. We got to catch some donuts. Make sure we avoid the bombs. Oh, we missed that one already. Avoid somebody threw a box. Oh, we're not going to get that one. Oh dear. We are not doing well. We haven't gotten a single donut yet. Okay, somebody threw a palm tree, another bomb. I haven't seen the donut in a while, have you? Oh, there's one. Please, please. Nope, missed it. Alright, we missed the fish and the bombs. Are we going to make it? Nope. Oh, please, let's get that one. Alright, we got one donut. Great. We're on a roll. Uh-oh. Alright, one donut. 53.4 meters. Ouch. That wasn't great. Okay, for sure you can beat my high score. So what I'd love to see is your high scores. Play around with your apply impulse. Play around with the scale of the player. If you scale the player up, you might have a bit more success getting donuts. Our player is kind of small when we're not changing that scale like we did here. Play around with it. See what you come up with. I'd love to see how many donuts you can catch and how far you can get. I'll play around with this code a little bit more. We'll check it out again tomorrow before moving on to our next one, Sound Poppers. All right, happy coding. We'll see you tomorrow. Remember to like and subscribe.